Hello students, welcome back. Today we are going to discuss about the gravitational potential energy. In the previous class we have discussed how exactly the acceleration due to gravity is affected by moving above the surface of earth, how it gets affected when we go below the surface of earth. So altitude effect we have seen, and we have also seen depth effect. Now let us move ahead. Now what we have to see is the gravitational potential. This is known to you in work energy, the work power energy we have seen it is mgh, right? So now how exactly we get? What is gravitational potential energy? Basically it is a work done in moving a body from one point to another point. You change the position of the body, that is what is the potential energy. You change the arrangement of two bodies placed, it is again potential energy. This is what we have discussed in work energy principle. So particularly we are talking of a gravitational potential energy, which means that the force which is responsible for that work done is the gravitational force. So we know F is equal to G m1 m2 by r square. This is the gravitational force. Now dW is equal to F dr. For a small change in the position dr, work done is F dr. So that is K q1 q2 by r square dr. This is dW. So therefore W is integration of dW. So that is K q1 q2 integration of 1 by r square dr. Suppose that we are moving from infinity to a particular point. Initial point is infinity, or you are moving from r1 to r2. Let us say from r1 you are moving to r2. This is what we have. Now integration of this, not q1 q2, this is m1 m2. This is m1 m2. So what we have is G m1 m2, and this will give us minus 1 by r from r1 r2. This is what we have. Now if we substitute the limits of integration, so what we get is W is equal to G m1 m2. You can take minus sign outside and you will get 1 by r2 minus 1 by r1. This is what is the work done. What is this work done? This work done is moving from 1 to 2. See? So we can say W from 1 to 2 is same as WR2 minus, you can say WR1. Right? But a minus sign is there. Minus G m1 m2. This is exactly what is change in the potential energy, or work done is change in potential energy. We can say, we can use this concept, change in the potential energy. So work done, this work done will be stored in the system in the form of its gravitational potential energy. See here, minus G m1 m2 by r2. Now suppose that we are bringing a body from infinity to a particular point, then what we will say, from infinity to a point r. So your work done there will be minus of G m1 m2 by r. That will be exactly how we will have from infinity. So your initial point is infinity, na? So if r1 is infinity and r2 is r, then W is equal to minus of G m1 m2 by r. This is exactly what we get, because 1 by infinity makes it 0. This is your gravitational potential energy. This is the gravitational potential energy of the system, minus of g m1 m2 by r. Now what we can say is the gravitational potential energy U. So U will be minus of G, M1 will be mass of earth, M mass of the body, and if I say it is R, this is what we have. Now if you want it on the surface of earth, then we will write R as radius of earth. If I want it on the surface of earth, so this is exactly what we can say as a function of r. Suppose that it is at a position, altitude is h, which is nothing but radius of earth only. Then I will write here r plus h. That is exactly what we can say, how to find what is called gravitational potential energy. Now, on the surface of earth, U will be minus G, mass of earth, mass of the body, and radius of earth. This is what we can say as the gravitational potential energy. Now this is also mgh. We can write the value of multiply and divide by radius of earth. Gm by re square is nothing but the acceleration due to gravity. That is exactly how we can find out the expression for the gravitational potential energy in terms of mg, acceleration due to gravity. This is in terms of universal gravitational constant, and if you write it in terms of acceleration due to gravity, you will take it as mgh. So both of them are interconvertible, they are same thing, but which terms are included in the expression, that is what is changing. So finally, to summarize, what is gravitational potential energy? Gravitational potential energy is the amount of work done to move a mass from one point to another point without disturbing the field, gravitational field in that region. That is what is the basic definition. Now suppose you say from infinity to a point, that is called the absolute potential energy of the body. Absolute potential energy, gravitational potential energy of the body is when we are moving a mass from infinity to a point. That is the absolute gravitational potential energy. Well students, the next term that we have to discuss is about the orbital velocity. Now what is the meaning of orbital velocity? The word only defines orbital. It is related to the speed of a satellite in its orbit. Suppose that, let us assume that this is Earth and a satellite is revolving where the radius is, let us say, r. This is what is the situation. Now in this situation, what we can say, this particular satellite is revolving with some velocity, that is orbital velocity. How much will be the orbital velocity? To estimate that, we have to understand how exactly that satellite is revolving in its orbit. Please observe, the satellite is revolving in, let us say, a circular path. If it is revolving in a circular path, this means there has to be a centripetal force, because I think you have done in circular motion. For a body to move in a circular path, essentially centripetal force is required. Without centripetal force, no body can ever move in a circular path. Since the satellite is moving in a circular path, this means that there has to be a centripetal force in, which is acting on the satellite. So what is providing the centripetal force? Closely observe Earth and the satellite. They are two masses, and law of gravitation says that there will be a force of attraction between these two masses. So the centripetal force required is provided by the gravitational force. So what we can say here, the centripetal force is provided by the gravitational force. Centripetal force is what? mv square by r, and this is F is g, mass of earth, mass of satellite, r square. This is what we have. Now simplify this. From this we can say mass cancels out, r cancels out, VO orbital velocity is root of this is exactly how we can find the orbital velocity, orbital speed of the satellite in an orbit of radius r. That's exactly how we can find orbital velocity. Now time period t will be how much? Time period t is equal to how much time does it, what is the meaning of time period? Time period is the time taken by the satellite to complete one revolution. So that time period is what is the distance it moves in one time period, once revolution. It is 2 pi r, and what is the speed? VO. This is what will give us the time period. Now we can substitute the value of V naught. So this gives us what? 2 pi r by V naught is root of GME, and here I will get root r, correct? So this can be written as 2 pi root of r cube by G into M. This is the time period. See how we can find out what is the time period of revolution of that satellite, provided we are able to understand what exactly is given and what is to be found out. Now you can find angular velocity. V is r omega, omega is V naught by r. You can find out the angular velocity also. Those things can be found out by this calculation. Now next thing is, what will be the, say, kinetic energy? Kinetic energy of the satellite, how much will be that? Kinetic energy is half m V naught square. This is the kinetic energy. How much will be that? Half m V naught square GME Therefore, kinetic energy is half of this is what we have. Also potential energy is what? Potential energy of the satellite is what? We have derived it, minus of G M by r. See, so this is exactly how we can say. So numerically, see, 2 times kinetic energy, numerically, if you don't consider the sign, 2 times kinetic energy is potential energy. This is what we can say. Moreover, total energy, and total energy is what? Kinetic energy plus potential energy. So total energy will be how much? Kinetic energy, half of G M by r minus of, this is what we have as total energy. So total energy works out as minus of G M by 2r. See, half minus 1 minus half. So this is what we get. See, students, observe, total energy is coming negative. What does that mean? This means that the satellite and the earth system is highly stable because energy is negative. Any system in which the total energy is negative means that the system is extremely stable. So here also, this satellite is highly stable in the given orbit. This means that the satellite cannot come out of the orbit on its own. Energy has to be supplied, work has to be done by the external agent to remove the satellite from its orbit. Now question arises, how much should be the energy supplied? Make the total energy 0, because maximum among the negative number is which one? 0. After that 1, 2, 3, 4 plus 1, 2, 3, 4 comes. So make the energy 0. This means supply this much amount of energy. So it will become plus Gmm by 2r. Then what happens is the total energy of the system becomes 0. Now the satellite can be taken out from its orbit. So these are the conclusions which we draw, and we are using this concept extensively to solve numericals. That is exactly how we can find. Just you see, students observe, we started with a simple concept of circular motion of the satellite, right? And you see how we can go on finding. Please practice, write these things once at least from your own side and try to understand how this topic can be tackled. Well students, now let us take the next very important topic from the numerical point of view in the entrance exam. Escape speed. The name only suggests escape. What is the speed required to escape? Escape what? Escape the gravitational pull of Earth. This is a very common example. If you throw an object up, it comes back to you. With what velocity I should throw it so that it should not come back? That is called escape. Why it is not coming back? Because the speed which you have given to the body is sufficient to overcome the gravitational pull exerted by Earth on the body. So it is able to overcome those pulling force and it is escaping the gravitational field of Earth. That speed is known as escape speed. Now see here, this is the surface of Earth and this is center of Earth, this is radius of Earth. Now from this point we are projecting with a velocity, let us say VE. This is the velocity with which we have projected. What happens is, on the surface of Earth, total energy will be kinetic energy plus potential energy. So that is equal to half m you have projected with a velocity VE minus of g mass of Earth into mass of the body upon radius of Earth. This is what we get as total energy on the surface of Earth. Now I want that the body should escape the gravitational pull. It should go out of the gravitational field of Earth. It should go to infinity. Normally we consider that at infinity energy of the body, any body, is 0. So if the body escapes from the gravitational field of Earth, then the total energy at infinity will be 0. Then what we can say? Then half mve square minus of gmm by re should be 0. So from this we can say half m ve square is equal to This is what we have. So therefore what we have now, VE is equal to escape velocity from the surface of earth, m cancels out, we get this as 2 times this is what is the escape velocity from the surface of earth. Observe here, G, capital G, which is acceleration, which is a universal gravitational constant, it's a constant. Mass of earth, it's a constant. Radius of earth, it's a constant. That is the reason why escape velocity from the surface of earth is close to 11.2 kilometer per second. This is from the surface of earth. Now suppose we start thinking, if any other planet is given, then what will be the escape velocity from that planet? So we can say escape velocity, speed from a planet P we will write root 2 G, mass of the planet upon radius of the planet. This is what? Replace mass by the mass of the corresponding planet, radius by the radius of that planet. You will get escape velocity from the surface of that planet. Now, if you observe, escape velocity is given as, on the surface of earth, can be taken as root 2 times orbital velocity. So this gives us important, say, conclusion we can say. Well students, let us take one question. This is conceptual. Find the percentage change in the speed of the moon to be imparted such that the moon escapes from its orbit. The question is, how much percentage change in the speed of moon should be given so that it will no longer be a satellite to earth? It's a natural satellite, so it will escape, it will break away from the gravitational pull of earth. That is what is required. Now here we can say, we know if it is orbiting in the fixed orbit, its orbit, then the orbital velocity is, this is the orbital velocity of moon, right? This we can say. Now what it requires, let us say this is escape velocity of moon. Now escape velocity is root 2 times orbital velocity. That is known to us. We have seen that, na? Escape velocity from moon is 2 times g mass of moon upon its orbital radius. This is what we can say. Escape velocity from orbital velocity is root of g mass of moon by r. So what we can say, the two, root 2 times. This means this is 1.414 times v naught. This is what we have. It is moving with what velocity? It is orbiting with a velocity v naught. Now in order to escape from the gravitational pull of earth, what is the velocity it should possess? It should possess Vm. Means it should possess a velocity which is at least 1.414 times the speed with which it is now orbiting. By some means, if we are able to increase by this amount, this should be the final velocity. So what is the percentage increase? So therefore we can say Vm minus Vo is equal to 0.414 Vo. This is the increase in velocity required. So the fractional change will be how much? Vm minus Vo by Vo. So this is 0.414. So what is the percentage increase? This means Vm minus Vo by Vo into 100. This will give us 41.4%. So if by some means the orbital velocity of moon is increased by 41.4% of its present orbital velocity, then moon will no longer be natural satellite to earth. It will escape from its orbit and it will come out of the gravitational field of earth. Students, let us take one more question which will correlate, which will try to help us understand the concept of escape velocity. A particle is projected vertically upwards from the surface of earth with a speed equal to 1/4 of escape velocity. What is the maximum height attained by it? What is given? Given u is equal to 1/4 of, let us say, escape velocity from the surface of earth. This is what is given. Now, total energy on the surface of earth should be equal to total energy at that height, because total energy will remain constant. This is exactly what we can say. So total energy on the surface will be kinetic energy on the surface plus potential energy on the surface is equal to kinetic energy at the height h plus potential energy at the height h. This is what we can say from the conservation of energy principle. So what we can say, kinetic energy at the surface is half mu square, because u is the speed with which it is projected minus of g, mass of earth, mass of body, upon radius, because it is on the surface, potential energy on the surface. This is equal to, what will be the kinetic energy at the height h? Now it says maximum height. We know that at maximum height the body will come to rest, therefore kinetic energy is 0. This is minus of g m by r plus h. This is what we can say. Now we have to evaluate this. How to evaluate this? We can say half mu square is equal to g m, we can take common, so 1 by r minus 1 by r plus h. This is what we have. Please simplify. So on simplification, what we get? Half mu square is equal to g m by, this is r plus e. If you take LCM, you will get h, and here I will get re plus h, and I will take here re. Carefully observe, the mass term gets cancelled out here. This mass and mass cancels out. So what we have is u square is equal to 2 times gm upon r into h by re plus h. This is what we have. Now we know that this is nothing but square of escape velocity. So we can say u square is equal to this entire thing. This is square of escape velocity. I can write it as ve square into h by r plus h. This is what we can write. Now substitute the value. How much is u? U is said to be 1/4. Square it. So we have what? ve square by 4 is equal to ve square into h upon re plus h. This is what we have. Simplify this. V square cancels. So from this we can say Re plus H is equal to 4 times H. 4 times H is Re plus H. So this means that 3H. So H is equal to, so this is the condition. So the maximum height the body will attain with the kind of velocity that is being imparted is h by 3. Students, please concentrate here. It is known that you know the value of g, you know the value of mass of earth, you know the radius of earth. That doesn't mean you go on substituting there. Please use this type of simplification. You will save lot of time there. So don't fall in the trap of substituting the value of g, m and r and all those things. Now students, let us take one more question. The question is like this. A body of mass m starts falling from a distance 2r above the earth's surface. What is its kinetic energy when it has fallen to a distance r above the earth's surface? Now, total energy when it is at h should be, or we can say 2r, should be equal to total energy when it is at the position r. So what we have total energy? So kinetic energy when it is at the elevation of 2r plus potential energy when it is at the elevation of 2r is kinetic energy at the elevation of r plus potential energy at the elevation of r. This is what we can say. Now clearly it says that it starts falling. So kinetic energy will be 0. Potential energy is minus of g m by 2r plus r. This is what we have, is equal to, what is asked, what is its kinetic energy? We need this. So this is asked, minus of g m by r plus r. This is what we have. So what we can say now? From this we can say kinetic energy on when it is at r will be how much? So shift it here. So we get g m I can take common. So 1 by 2r minus 1 by 3r. This is what we can say. So therefore kinetic energy at position r will be, we can take g m by r you can take common into 1 by 6. This is exactly how we can find out. Now if you want this, you can write it as, see, or kinetic energy at r is r multiply divide by r. So g m by r square, m and r into 1 by 6. Now gm by r square, this expression gm by r square is acceleration due to gravity. So I can write this as mgr by 6. This is also we can write same thing. It is same as this. That is how, see students, how they are interconvertible. Well students, let us take one more question. If you concentrate all these questions, we are using one principle, that is law of conservation of energy. So students, try to become more conversant using this equation, then your calculation will be saved a lot. With what velocity must a body be thrown from the earth's surface so that it may reach a height of 4 times Re above the surface of earth? So again students, here this question deals with law of conservation of energy. So what we can say here, total energy on the surface should be equal to total energy at the given height h. So total energy will be what? Total energy is given as kinetic energy on the surface is equal to plus potential energy on the surface is equal to kinetic energy at height h plus potential energy at height h. Now with what velocity must a body be thrown? This means we are imparting initial velocity. So this means half mu square. Let the initial velocity which is given is u. So the kinetic energy in that case, in that situation will be half mu square minus of g m by r. This is what is the potential energy on the surface of earth. This is equal to, we need that it may reach a height. When it reaches the height of 4 times radius of earth, it will momentarily come to rest. So this kinetic energy is 0 and potential energy minus of g mass of earth into m by re plus 4 times re plus h. This is exactly what we get from the law of conservation of energy. Now simplify this. So half mu square, we can write it as, we can take g m by re common. So what we have? 1 minus 1 by 5. This is what we have. So what we get finally? Finally half mu square is equal to gm. So we have this as gm into m by re into 4 by 5. There are many ways by which we can simplify this expression. See here, this m and m cancels out. So what we get is u square is 8 by 5 into, you can write here gme by radius. Now students, there is no need to substitute the value of g, m and e. Convert this into what is called as the expression which will involve acceleration due to gravity. So this will be what? 8 by 5 into, we can write g into radius of earth. This is what you get. So root of it is your speed with which it should be projected. Further, it can be simplified. You can substitute the value of g as 10. You can substitute the value of radius of earth as 6400 into 10 power 3 meter per second. You can definitely do that. See, you can leave here also. Otherwise, you will work out as square root of 8 by 5 into g is 10 into 6400 into 10 power 3. So you can simplify this. 5, 2. So you get 16 into 64 into 100 into 100 and into 10. So 16 root of it, you will get 16 is 4, 64 is 8 and 100 will come out and you get root 10. This is exactly how you can simplify and you can work out what exactly is the value of it. See, close to this we can work out, or you can leave it here also.